Hi guys, so today we'll be solving this problem called count ways to build good string. In this problem we've been given, let's read it first. So we've been given the integer 0, 1, low and high. We can construct a string by starting with an empty string and then at each step perform either of the following. Append the character 0 0 times, append the character 1 1 time. This can be performed any number of times. A good string is a string constructed by the above process having a length between low and high. Return the number of different good strings that can be constructed satisfying these properties. Since the answer can be large, return it modulo 10 raised to 9 plus 7. So yeah, in this problem, we've been given low and high value, and the number of times 0 and 1 can be added to or appended to the string, and the number that is the basically like 0 can be appended one time, 1 can be appended one time, right? That is the idea. And we need to return the strings which are between low and high, which is here 3. So we need to return number of ways we can use 0 and 1, like these operations 0 and 1, to form a string which is unique and different, right? This is kind of similar to the coin change problem, and we'll be using dynamic programming to solve this, right? So in dynamic programming, we know that first of all, we'll create an array of length high plus 1. So 0, 1, 2, and 3, right? So that is the length. So I know that of 0 length, I know that there is one possible option, which is an empty string, which is possible, which does not require adding 0 or 1s, right? So one possible option is there, right? So that is the answer for the 0th position. The going further, all the values will be having the faith that the previous answers or the previous index has my answer, and I just need to append a 0 or 1 or whatever operation I need to do. So for example, at one position, right, if I want to create a string of 1, right, 1 length, so I know that there is a possible empty string is possible in one way, right? And I just need to append myself to it. So I just need to append a 0, 0 number, one number of times. So 0 is appended one number of time. That gives me one unique string. And I also know that 1 is also one number of times. So that gives me a one unique string. So there are two possible options. So which is like dp of, you know, I, which is 1 minus the number of times 0, right? So 1 minus 1, right? So that is, we need to add that. So that is 1, right? So dp of 1 minus 1 is 0. So that is possible 1, right? dp of 1 minus 1 is 1 again. So 1 minus 1. So here we are using this length. So 1 minus 1 is 1 here. So I'm assuming that previous strings which are like having, so I know that of length 1 string I need to go to minus 1, which is here, right, 0. I know and I have the faith that that index has the possible values or possible answer for all the possible values or strings which can be formed of that length, right? So 0 is having 1 as the operation, right? So one possible answer for it. So we are just going to use that and append the 0 or 1 to it, right? So going forward, we're at 2. So dp of 2 minus number of times that 1 needs to be appended is 1, right? So which is dp of 1, and dp of 2 minus 1 is dp of 1 again, which is this one we are using. And so let's do it with an example. So I know that at one position, right, there are two possible strings, so 0 and 1, and I just need to append two things to it, right? So I can either append 0 and 0 form like this, or it can also form like this, right? And 1 can also form like 1 and 0 like this, or it can form 1 and 1, right? So I have four possible combinations here. So I'm just going to use, so 2 plus, so this will give me, like, I can append this one and this one, right? So that is the two possible option. This one and this one is the two possible options. So 2 plus 2 is 4. So there are four possible options here, right? Going forward, here we have at 3 minus 1. So 3 minus 1 is like number of positions, like 0 and 1 needs to be appended. So dp of 2. and dp of 2 again, right? So what is the possible answer here? It's 4 times, right? So 4 plus 4 is 8. So there are 8 possible combination of three length string, right? And we know that this is between the low and high. So I'll add it to the result, and essentially that is the answer for the first example. Let's get to the coding part in order to understand this better. Let's get to the coding part. First of all, I know that I need to create a DP. So I'm going to create at the 0th position, right? 1 plus, and I know that it's going to be of high number of times, right? I need to create a result 0, which will be adding all the results, and I also need a mod as recommended in the problem. I'll iterate through the from 1 to high plus 1, right? And let's see here what are the things that we can do here. So first of all, I know that I need to use the previous answers. So if I is greater than 0, so dp of I equal to dp of I plus whatever is that there at the I minus 0 position. I need to use that and add it to the dp of I current position, right? So if the next one is if I is greater than equal to 1, right? So dp of I equal to dp of I plus dp of I minus 1, right? Whatever is at the I minus 1 position, I need to use that, and I'll modulo it. Similarly, I have here, now I know that, okay, I have created the dp of I or possible values, which is possible at the ith index. I'm going to update the result as well. So if I is greater than the low, right? Low string, which is the range that we need to know that between these range, we need to return the different possible strings. So between these range, which is greater than low and less than high, greater than equal to low and less than equal to high, I need to add it in the result. So the high one will be taken care from here because we are iterating from 1 to high plus 1, and the low one will be taken care here. So result plus dp of I modulo, right? And yeah, then we return the result in the end. That is the idea. Let's run it to see if everything is working fine. That works. Cool. I hope you guys understood the problem. Thank you.